Alright, I'm Porter Squires. I'm going to be doing the Game Builders Club tutorial. The tutorial will be using this repository, github.com/gamebuildersclub/relic defense siege of the void, this awesome name. To follow along with this tutorial, you can use this GitHub. I'm going to have different branches. Asset supplements will contain different assets, sprites, etc. that will be used in the project. And then week 0 is the branch that we will be concerned about. This is the base. We just make a game in Unity project using the 2D URP setting. So, first, you need to clone the repository if you haven't already, or if you want to make your own project, you can. If you want to clone this, you can use the URL and then just paste this URL, the first part of it, right here into here. I already have this downloaded, so it gives me this message. If you do not already have the project on Unity, I will just remove it to show you how to get it. If you go to the little drop down for open, add project from disk, go to wherever you are storing your GitHub folder. If you hit Control-Shift-F when you're on GitHub desktop, it'll bring you to this. So it shows you the file path up here. I will select it right here, just select this folder, add project, and bam, there it is. The first time you start up the project, it will take a little bit to load just because you may not have downloaded the packages. I've already opened this on my computer, so it'll be a little bit faster. But it will do this installing packages message for a while. I'm going to switch to week 0 because that is the starting point. And I'll branch off of week 0 to week 1 just so that we have a branch which we can use later on. Now all my changes will be stored in the week 1 branch on GitHub. I'm also going to merge the asset supplements branch in here because this contains sprites that I added. So if you want to, on your own branch, if you are on your own computer, sorry, select a branch. I'm using week 1, you can do any. Choose a branch to merge it into week 1. Select asset supplements, and you can create a merge commit. If you do not do this, you will, under assets, under sprites, you will not see the characters wise one. So if you're missing these images, make sure to follow this step. Alright, so if you have not opened a Unity project before, I'm just going to go over the windows. At the bottom, we have the asset menu, this project window. You can see it's basically a file browser. So if we wanted to, we could right click one of these and we could do show and explorer. This shows us the same folder in our file browser that we can see here. We don't see the meta because that stuff is unnecessary. But we do see all the relevant files. And because we merged the asset supplements into here, we can see sprites, characters, wise one, and then we have all these images. Over here on the right, this is the inspector. If we click on a file, it'll show us any data about it. If we go to the scene, this is the scene view. It shows us what's in the scene. You can scroll out using the scroll wheel. You can click and drag with the scroll wheel. These are the tools on the side. If you hit the pan tool, it does the same thing as clicking and dragging with the scroll wheel. It lets you move around the scene. If you hit this tool, the move tool, you can also hit Q for the view tool, by the way. Q for this, W for the move tool. If I selected object, so let's say I'm going to select this global light 2D, it gives me these arrows to move it. If you are in 3D, you'll get another axis, but we don't have to worry about that. We can hit this button to make sure we're in 2D because we're working with 2D game. There's also the rotation, so we can rotate things by dragging. There's scale, so we can scale it. It doesn't have any effect because it's the global light, which doesn't actually have a shape to it. Besides, yeah, it doesn't really have a shape. There's also the rect tool, which is useful for other things. Let me make an object so that I can better show these tools. By the way, Q, W, E, R, and T are quick shortcuts when you're in the scene view for these. This is the hierarchy over here. This shows you all the objects in the scene. Main camera is this box right here. So if we select this, it'll also show us what the main camera sees in this little window down here. If we hit W and move around the main camera, we're moving the view. Here's the global light 2D. This is what I clicked on earlier. And then this is an empty game object. I just made this. You can make an empty game object by right-clicking here and then create empty. It'll make the same thing. One important note is every object has a transform. Empty game objects will only have transforms. That is why they are empty. Other game objects, such as Global Light 2D, will have some script or component to them. These are components that we see in the inspector. The main camera has the camera components and an audio listener and this camera data script. Besides the hierarchy, we also have the game view. So at the top here, we can hit game, and we see basically what we see in the camera. Let me make a sprite. So if we right click here, we can go to 2D object, sprites, and then we can hit square. This object is good to showcase the tools, so we can move it around with these. We can move it on one axis. We can rotate it. We don't really need to use these to rotate it. It's kind of weird because it's 3D. If you want to do cool effects, you can do that. But otherwise, just use the blue one, which is rotating along the Z-axis. We can scale it like so. We can also drag that to scale it along all three. And then we get the rect tool, which is, this is typically used for UI. So you might not necessarily use this when editing shapes in the scene, but if you use UI, it's very useful. Okay, now that we know all of the windows, before I forget, one last thing. You can drag all of these windows around. So if I could drag project here, we can pop it out, move it around, move it onto my other monitor. We can put inspector down here. We can put hierarchy over here. We can totally screw up everything. If you go to window at the top, layouts and default, it'll reset it. So if you screw up your windows, that's how to fix it. If you don't see anything here, just hit the drop down. That little star means we don't save our scene. For GitHub, the scene is considered one file. So whenever I change this scene, I am going to be changing the scene file. We can see that it changed. Be aware of this for Git commits when you and other people might be working in the same scene. To avoid working in the same scene, you can make another scene where you'll make all your changes. So right now I have dev scene. I can go to right click here, create, or sorry, this is the one asset technically. You won't be right clicking here. Usually you right click, create asset. What you do instead for scenes is you go to file, new scene, and then I could just choose the default lit 2D URP. That lit means uses light. Create that, and I will be working in this scene. If I hit Control S to save it, it'll prompt me to save, so I can finally go here. I'll save it dev scene week 1. And then any changes I make in this scene will be good. Just be aware of how to mess with the scenes in case you're working with other people. So, first thing is we want to get something in the scene, something to work with. If we go to sprites, characters, one, we have a bunch of images that we want to use. When you import an image in the inspector, there's a few values. This is a pixel art image. If we double click this, we should be able to see it. There's different frames of this guy. So we know that sprite mode will be multiple. It's not a single image, it is multiple images. Pixels per unit is the size. Making this smaller makes the image itself appear bigger in the scene. And since it's pixel art, we don't have any pixels, so we need that small. For filter mode, we want point, no filter, and compression, we want none. This will make the pixel art nice and crisp. And then in the sprite editor, after applying your changes, we can slice up the images. So when you first do that, it might not be sliced properly, or it might slice it automatically. So I have aligned my images into a grid. If you want to slice these, you can choose grid by cell size. This gives you a bunch of options. I know I want 64 by 64 squares, but they're misaligned. I can add an offset of 32 by 32 to change the top left starting box. And then I can either do this, because if you slice, it will ignore any box that doesn't have anything in it, or I can be more specific and add padding, 64, 64, so that it's just exact. Either way, we end up with 9 images. And then we can hit this arrow after slicing it, and we can see all of our different images. If we drag one of these into the scene, we will get one object. It is the wise one block, since it's the wise one blocking animation 0. It's the first image. This object has one component on it. It is the sprite render, and it's already using the sprite here. Let's say we want to make this into an animation. What we can instead do, I hit delete that, and we can just drag the image itself in here. Now it's going to prompt us to make an animation, because it's like, oh, you have a bunch of images, let me make that into an animation for you. So we'll make a new folder here, animations, and then save this, wise one blocking. And now, if we go to window, to bring up the animation window, we can go to window, animation, animation. Now we have this window. I can drag it down here, and I can hit play, and we will see the animation playing. This uses frames, so on frame 0, frame 1, frame 2, we have these keyframes where it switches the actual sprite here. So we go 0, 1, 2, 3, 4. The animation tool works by changing values in the inspector. Let's say we wanted to make this frame last a little bit longer. We can drag over here, move it over here, and then the value over in the inspector, the sprite won't change when we get to 3. So when it gets to 4, it will change. Control Z, undo that. If you want to speed up or slow down the animation, right here it says samples. If we hit 24, or sorry, if we type 24, enter, and it'll switch to 24. That makes it speed up. Bring it back to 12. It slows down. That changes your animation speed. You can also change it by just manually dragging these out, but this is an easier way if you just have frame by frame animation. So the next thing, once we have our animation, we want to make another one because we also have a walking animation. So I'll just create a new clip here while selecting the player game object. I will name it wise one idle. We have nothing in here. So I'm going to drag this window up here just for convenience. I've already imported the wise one idle animation with the correct stuff, so I can click and then shift click at the first and last and then drag them in here. That will drag in all of the different images. I believe there is 7. Yeah, we should be good. And then if we hit play, you'll see the animation's going really fast. That's because the samples is at 60. I can switch that to 12, and it will look good. And we can do that with a bunch of other animations. After making our animations, we can go to Animation Animator. There's a very distinct difference between these two. Animation is just the single animations. Animator uses all of the animations. So if we click, make sure the game object is click. I'm just going to rename it real quick. This is a player. If we click and then click again slowly, we'll be able to change the name, or we can right click and rename. We see a bunch of states or nodes in this animator window. We see wise one blocking and we see wise one idle. The entry node points to the default state, which is highlighted in orange. When you start the game, this will be this state that's active. So the player will be blocking when we start the game. We don't want that, so we're going to right click wise one idle, set as their default state. We can just move this over here to make it nice, and we will start out wise one idle. And then if we go back to the scene or game, we can hit play. It'll switch to game view. When we start the game, it'll be idling. Just for an example, if we wanted to see what it looks like if we block as the default state, it'll just keep looping the block animation. Now that we have these animations attached to our player, we need to actually move them. Maybe we should make the run animation first too. We could do that real quick. Create a new clip, wise one run, move it up here, open the wise one run, click, shift click, drag into the window, move the window back, change sample to 12, hit play, and we can see running. Perfect. Go to the animator. Now, when we're actually playing, there's no way to transition, well, we haven't made a way to transition between these states. What we need to do is we need to right click, make transition, click on whatever you want the transition to be. So if I want to transition from wise one idle to wise one blocking, I can, after right clicking to make transition, click on wise one blocking. Now we have a transition from wise one idle to either of these two. There's conditions for transitions, or you can have a transition occur exiting an animation. So right now exit time is set to on and 0.625. So after 62.5% of the animation is done, it will switch to wise one run. We don't want that. We want wise one idle to continue until we tell it to go to run. So we're going to turn off exit time. We want that transition to be instant, so we're going to set transition duration to 0. And then we need some condition. Up here, there's these little tabs. This is layers and parameters. Under parameters, we can hit the plus, add we'll say trigger. We can say block, and then we'll add another, and we'll say bool, running. The difference between, well, float is number, int is also a number. Float is a decimal number. Bool and trigger can both be thought of as booleans, or true-false statements. The difference is that when trigger is used as a condition, it will automatically be marked as false. So a trigger only happens once. A bool will be true until you tell it to change back to false. So if you have a button that does something, it's good to use a trigger because it will only happen once. But if you want to hold down a button to keep an animation going, then it's probably good to use a bool, which is why I use running. While we're holding down the A or D key, will be active, and then block is a button. We'll only use it once. So for conditions, for the wise one idle to wise one run, with the plus, running true, perfect. Then we want to make a transition back. So when we're done running, we can right click here, drag over here. When we're done running, we want it to be instant. So remove exit time, transition duration 0, running false, it will go back to wise1 idle. For wise1 blocking, because we want, let me real quick fix this. So we want the transition to be instant. Conditions blocking. And trigger is just when it's true. It will, if you select it as a condition when it's true, it will trigger this. Now we want the transition back. If we use exit time 1 and transition duration 0 and no conditions, it will wait until 100% of the animation is done and then instantly go back to wise1 idle because transition duration is 0. Perfect. So now we have our animator. We have just a simple thing. We have idle, run, blocking. Let's go back to the scene. We need to make the player move now. We don't actually have any scripts to run anything. Real quick, before I forget, we need to make sure this animator is enabled. It by default is unchecked. That's because I dragged it in and it created it by default, just automatically. Make sure that's checked. So to create a script, I will go to the scripts folder. I'll make a new subfolder. Name it player, just for better organization. And then again, right click, create C# script. I will name it player controller. And then if you, normally this won't happen, but when I double click this, it will open Visual Studio. This is supposed to happen. This is good. If this doesn't happen, or you end up with errors using Visual Studio, if you go to Edit, Preferences, and then go into, where is it? External Tools. Make sure External Script Editor, you have selected Microsoft Visual Studio 2019. That will properly use Visual Studio and hopefully fix any IntelliSense errors you have. So, clicking on the script, if you're new to scripting or coding, there are a few things to pay attention to. First, we are using the Unity engine. We need this at the beginning whenever we work with Unity stuff. It's there whenever you make a script, so you don't need to worry about it. Everything is organized into classes. So we have public, class, player controller. Anything you will attach to a game object, like these components over here, we have the animator, sprite renderer, transform. Any script you want to attach as one of these to a game object to make it work with it, you want mono behavior right here, so colon mono behavior. Our class player controller has a bunch of stuff in it. These curly brackets, anything in the curly brackets means it is in the player controller class. We have the start method and the update method. A parentheses indicates that it is a method. Anything in the curly brackets are the instructions for the method. Start and update are Unity specific, so anything that is a mono behavior and is attached over here as a script, it will look at these methods, start and update, and automatically call them for you. Unity also has a few other methods like that, so fixed update and awake are also Unity specific. The order in which these are called, I'm going to cut paste this up here just to make it make sense. Awake is called before any code works in this class. Start is called before the first frame update. So awake happens, then start, then update happens, or then these two occur kind of simultaneously. So update occurs once a frame is rendered. Fixed date update occurs in time with the physics engine. You don't have to worry too much about these if you get into the mechanics of how it works. You will end up realizing this is whenever you want to draw something or every frame update, and this is whenever you want to work with the physics engine. You don't have to worry too much about that right now, though. We could just delete all this. And what we want to do is we want to make a variable. We want to access this transform, or sorry, we want to access this animator because we want to make the player run. We want to change this running and blocking parameters. So I want to store the animator. Type animator. We can name it anything. Anim is a good short name. Usually you should make your variable names more specific, but animator is used so much that it's okay to use it that much. So you can add serialized field here. What serialized field does is it allows you to see the variable in the inspector. This is a tag. I forget the proper name for this, but serialized field, add that. It applies to the variable, the animator named anim. You'll get a value in the inspector similar to these right here. You can change it using the little circle. So adding serialized field to anim will add a field similar to there when you add the script. Then I can save and we can add the script. We can either search for player controller, it'll be right there, and or we can use the asset menu and we can attach player controller over there. And there's the little field right here. So we can drag animator into this field and then we will have a reference to animator from our script. Now that we can access it, since we have this reference, we can start messing with the methods that it uses. So we're going to want to make a method to just change basic Boolean, whatever the variable is. So first we need public. Public is a visibility. It is a good default visibility to use. Normally private and protected are good visibilities because they hide it, and that is a good principle. It is a good principle to follow to keep everything hidden, but in this case we want public because we want to access this method, use it somewhere else. Void is the return type. We're going to return nothing, so we just use void. And then we can say set running. We're going to add a parameter. Bool is running. Bool is the type. And then curly brackets. Anything in these parentheses is a parameter. So this is the type of a parameter, and then this is a value, the name of the parameter. We can have more parameters by doing comma and then specifying something like int, which is an integer number, some number, but we don't need that for now. We could just use bool is running. If we want to set the animator parameter for running, so that it switches to running, we do anim.set bool parenthesis, and then we can give the name of the value so we know it's running, and then comma, and we set the value, so is running. This is the value we pass in here. The reason we made the method like this is so that we can call from anywhere. Given a value, we set a bool to the value we give it. It would be easy to say instead of this, anim set bool running true, so that we know every time we call this method, it makes it so the transition occurs in the animator, but we want a little bit more customizability, so we're using a parameter. So after that saves, we now have a method to change running. We now need a way to get input to the player. How we'll do this is we will use the Unity input system. If you have researched input before, I'm just going to make a real quick method to show you what you might see. Input.get access raw might be a suggestion, and you can give an access, for example, and this will give you a value. So if you hold down A and D, this will give you a -1 or 1 value. What we're going to do instead is we're going to use the Unity input system, which is a new package that makes input a lot easier to work with. So going to Asset Store, we can open Package Manager or Window Package Manager. Unity input system is a package. We want to look for it, so we need to make sure packages in project, we're looking at Unity registry. That way we can find it. Input system. And then we have it right here. Hit install. And then it will ask us to restart because it is changing some settings in the project. All right, it's asking if we want to restart. Say yes here. This will make it so that the previous input system, the way I showed you, get access raw, will stop working. This is fine because we want to use the new input system. So it's going to restart real quick. Well, I say quick, but depending on how long it takes to load. It's usually pretty quick if it's a restart like this. All right, is restarted. So now that we have it downloaded, we need to do a few things just to set up the input system for the first time. We could start by saying add component and say player input. Select player input. This is the main thing that the input system adds is this component right here. This component involves using a set of input actions. You can either make a set of input actions by going to create, going down to input actions, or you can hit the create actions button right here, and it will just assign it right here. I'll save it. I'll put it in a new folder called input, and we can, oops, select the wrong folder. We can just name it something like controls to make it easy. And then it creates a default action. So the layout of this, we have action schemes. Right now I created a gamepad, joystick, keyboard, mouse, touch, XR, augmented reality, I believe. We can add a control scheme if we wanted to. What this does is control schemes deal with devices. So if I wanted to add a keyboard control scheme, we can hit the plus. For some reason, it's a little buggy on my version, so I have to use the arrow keys to navigate this. Clicking it doesn't work properly. So I can hit space, or sorry, hit escape. Hitting the very edge works apparently. Keyboard required, yes. We already have that, so we don't really want keyboard again, so we can just delete this control scheme. It's nice to have the default because it has a lot of useful things. So, how the action map is set up is we have action maps. These are categories of different actions. So we have player and UI. Player just has a few: move, look, and fire. These are the actions. UI has a bunch of different ones, which we can ignore for now. Under these different actions, they each have a type. So this is a value, and then it has a vector 2 as the value, which is an x and y value. Look is also a vector 2, that's just looking around with like your mouse, for example. Fire is a button, so you click it and it happens. It's just a button action type. We can hit the drop down and we can see that for move we have a WASD. That uses keyboard and mouse. It's not showing us other ones right now because we currently have the control scheme keyboard mouse selected. If we hit all control schemes, we see move also has left stick for gamepad, primary 2D axis for augmented reality, and stick for joystick. But we're only worried about the keyboard mouse, so we can click that. WASD is a composite type. If we wanted to add something similar, we can hit the plus right here, add up, down, left, right composite. And we can copy what's above. We don't need that, so I'll hit delete. And we're good. We could just use the move right now, which uses WASD controls. The path for this is W on the keyboard. We can hit search, search up here. I don't know why it's bugging out like that. It might be the version of Unity. But yeah, we have move, look, and fire. Close this. We need to go to input, click on this, and then check generate C# class. This is relevant for us working with the input system that we made. So after it makes a class, go back. It has the input action selected over here. We can just leave these settings over here. Switch behavior to invoke Unity events. This gives us the events dropdown. You could ignore these methods right here. If you open the player, this is the action map that I showed you. It has move, look, and fire. I want on move, I hit the plus to add an event, a Unity event. And then it says runtime only. This will happen when I hit play. I can drag an object in here, so I'll drag in the player object. And then I can call something on the player object. Right now we have the player controller on here, and we made a method called setRunning right here, which takes a bool. You can call methods that only take nothing, bools or strings, or simple values like ints from this Unity event. So we can set setRunning true. So now hit Control S. When we play, it'll be default on the idle animation. We hit any button that moves, like WASD, and it switches to setRunning. Perfect. But that's a little bit weird because we hit it and then it just starts running forever and it doesn't even move. We haven't even added the move functionality. What we want to do is add a little bit more complicated stuff. So for setRunning, instead, let's name this move, and then we're going to take a different value. We're going to use a value specific to the input system. So we're going to say using Unity engine.input system. And then in the parameter, we're going to say input action dot callback context. We can just name it ctxt, short for context. This is the variable that it passes in. This has anything relevant for working with the events it gives us. So remember that we can go to the action map. We can see move is a vector2 action type. So if we type context dot read value to triangle bracket and say vector2 because we know that we're going to be wanting a vector2 from the move, parenthesis, this will get us the vector2 value. So if we hit just A, it'll give us -1 for X, 0 for Y. We can store this in a variable, so say vector2 direction equals, and store that. And then we're gonna want to set running to true if it has a value, or if it has any values greater than 0 or less than 0, because that will mean that we're moving in any direction. So what we can do is we can say bool is moving. We can set a boolean equal to direction dot magnitude. This is the magnitude of the vector is greater than 0. So if it has a value greater than 0, is moving will be true. Then we can set the bool is moving right there. Go back to the player. And then we change the name of the method so it's not being set there anymore. It has set running there right now, but that won't work because we removed that method. If we go to player controller now, this is dynamic callback context. This means that this method has the specific, or it has as a parameter, the specific variable that these Unity events will be using. So we can select move. Now, if we hit play, we should be able to control when the player moves or does the running. So I hit D, starts moving, let go, stops, hit W, S, etc. Now we want to actually get the player moving. To do this, we can change the transform. And so to do that, we can either manually just add an X value every frame that we know we're moving in a direction, or we can use something that or we can use the Unity physics system. I prefer the physics system whenever working with the input system, just because it calls an event and we can say set the velocity to this and we don't have to do anything else. It's just a one-time click, you got your speed. So to use the physics system, we need a rigid body, 2D, since this is a 2D game. We'll add that component. I believe that's all we need, just if we want to move the player around. So if you want to do collision, you'll need to add some collider, but we don't need that right now. We need to get a reference to this rigid body from the player controller, so we can make another method or variable. So we add serialized field to see the variable inspector, and it is going to be a rigid body 2D. We can name it RB since it's also a frequently used variable name. So we get the field in the inspector over here, and we can drag in rigid body 2D there. That way we have the reference in our script. Now, what we can do is in the move method, we need to set the velocity of the rigid body to be something. So we can do rb.velocity equals direction. Simply just direction. We don't have to change it to any amount because direction is just going to be a vector with magnitude 1 whenever it's not 0. So it'll just send x and y in a direction because the rigid body 2D velocity takes a vector 2 and direction is a vector 2. And then if you were to use a normal rigid body, not a 2D, you would use a vector 3. So you'd set the x to the x, a y to the 0, and z to the y value to actually map it, but we won't have to worry about that for now. So, hitting play, you can see that it moves, it falls. That is because we have not set the gravity to 0. So, go to gravity scale under rigid body 2D, set it to 0, save, make sure to always save. And then, it is properly working. And as you can see, it is very slow. So, what we need to do is, let's get another variable, so we can change this in the inspector. We can say float speed, and we'll set it to like a default of 5 or something. Now, we can do direction times speed. That will multiply the values in direction by speed. So this will make you move faster, basically. A lot of Unity is working with vector maps, so if you're not comfortable with it, I highly recommend learning up on it. So now we have this value 5 here for speed. We hit play, and we will see we are moving much faster. If you want to, you can change this value during runtime. So I will change it to 10. I can type and then do that, or I can drag the name of the value itself, go really fast, or flip the speed. I'm holding right and it's going left. That's bad to do. Make it really small, go really slow, go really fast. Note that it's 14.46 right now. I hit the play button and it stops, goes back to 5. Remember that anything you do in the inspector while it's playing will go away because your scene is saved as a file. Whenever it stops playing, you're looking at that file that you saved earlier. So it will not store any changes you did in the inspector. So just remember that if you're making changes, make sure it's not playing so that your values are good. So if I thought 10 was good, after testing that, I can set it to 10 right here. And then hit save. Yeah, and I believe that covers most everything I wanted to do in this tutorial. So we learned the basic layout of the screen. So we have the asset menu, the inspector, the scene view, and the hierarchy. We also have the animation. So importing the sprites, we were able to create animations for that. And then we saw the animations in the animator, these different states and the transitions between them, creating conditions, creating parameters for these conditions, and then using a script to receive input and then using the input to change values in the animator and change rigid body velocity. Next time, what I will be doing is I will be going over uh, creating or dealing with colliders, dealing with triggers from colliders. So if I want this guy to punch somebody, hit an enemy, it'll hit the enemy and something will happen, like the enemy will lose health. So yeah, thank you for watching, and please message at Purter on Discord if you have any questions.